Hello and welcome to the Tech Mojo. This is Nilan, and today in this video we will see how to import the large CSV data into PostgresSQL using Spring Batch. Spring Batch is a powerful module of Spring framework that provides out-of-box implementation for batch processing tasks. It is used in the scenarios where the data need to be processed in multiple batches. For example, if you want to generate a daily report or periodic import of your data into the database, or any complex calculations or transformation on your data, you can use Spring Batch for that. A typical batch processing application involves following steps. We first have an input. The input can be the data within your existing database, or it could be the data within a file. First, we read the data from the input source, and then we transform the data, and once the transformation is done, then we validate. In the transformation step, we basically take the data from the input source and then convert the data into whatever format we're looking for, typically converting that back into the Java object. The validation step ensures the data integrity is maintained. It just makes sure that the data is valid before it enters into your system. Once the data is transformed and validated, the next step is the process step. So process step is where we write our business logic on the data, and then we do all the processing required. Once the data is processed, then we serialize the data, and after the serialization is done, then we save the data into the output source. The output source can be a database or a file system or any other third-party source you have. This is a typical process how the batch application or batch processing is done within an enterprise. Now, all of these above steps can be achieved without using Spring Batch. Then the question arises, why do we need Spring Batch at all? Do we need this framework? Let's dive in. Spring Batch provides industry standard architecture for performing the batch import operations. So we don't have to reinvent the wheel. It makes it easy because the developers and the architects are already familiar with the pattern, and it makes the code more readable and easy to maintain in a long run. It also seamlessly integrates with the Spring ecosystem, and we can take benefit of the features like dependency injection, auto configuration, transaction management. So all these features can be integrated seamlessly with Spring Batch. Spring Batch also provides chunk-based processing. What it means is if your input data source is huge, then instead of processing the huge data set in a single batch, you could break down the data set into multiple chunks and process chunk by chunk for efficient processing. Spring Batch also comes with I/O capabilities, and it supports a wide range of data sources and targets, including the different type of databases, XML, JSON reading, or reading from a flat file. All this can be easily done with Spring Batch. It also provides a detailed monitoring and logging support. By using the Spring Actuator, we can track the jobs and step execution, and it makes it easier to understand the status and performance of your batch operations. Now, all this benefit that we just talked about makes a strong case for using Spring Batch instead of writing your own logic and implementing your own batch processing job. Spring Batch provides two ways to implement a job. You can process the data using tasklet or using chunk-based approach. A tasklet is a single task within a step, and the tasklet interface basically defines a single method called execute, and the method is called once during the step execution. A chunk-based approach is more suitable for processing the large data set, where the data can be read and processed and written in a smaller, manageable chunks. This is typically used for reading the data from a database or a file system and process the data record by record. The chunk model is built around three main components: a reader, a processor, and a writer. In the later part of this video, we will understand all these three components more in details. We will see how to use them within our batch job. Now let's look into what are the key components of a Spring Batch application. The Spring Batch application includes something called a job, a step, the readers, writers, and processors. Then we have job repository and job launcher. The job launcher is an interface that is responsible for running the job. It takes care of receiving the job parameters and launch the job with those input parameters. The job launcher is used to start a job from different trigger, such as from application event or from a REST API call or from a scheduler or any sort of cron job you can use to trigger a job. A job in Spring Batch is an entity that encapsulates the entire batch process, and it is defined by a series of steps. A single job may have one or more steps, where each step is typically involves in reading the data, processing it, and then writing the processed data to the output source. The item reader is responsible for reading the data from different input sources, such as from database or from file system. The item reader has a read method, and every time the read method is invoked, it returns one item. If there are no more items to read, then it returns a null object, which indicates that it is the end of the input. Spring Batch provides multiple implementation of the item reader. For example, it comes with a flat file item reader, JDBC cursor item reader, and also JPA paging item reader. The flat file item reader can be used for reading the data from the flat files like CSV files, and we can use the JDBC cursor item reader for reading the data from a database using the JDBC cursor. Similarly, we can use the JPA paging item reader to read the database records in a paginated manner using the JPA API. It is particularly useful when we are dealing with a large data set which cannot be loaded into memory at once. The JPA paging item reader fetches the data in chunks and processes each chunk separately. This helps to efficiently process the large volume of data by utilizing less memory and also improves the performance. In this example, we will read the data from the CSV file. So for that, we will use the flat file item reader. Similar to item reader, we also have item processor. The item processor is a completely optional step. You can use the item processor to validate or transform or filter the data before the data is passed into the item writer. The item writer takes the processed item or data which was passed from the item processor, and then it writes the data to a database or the file system based on whatever output source is attached. Again, for the item writer, we have multiple implementation of item writer already provided out of box. We can make use of flat file item writer to write the data to a file system, or we can make use of JDBC batch item writer for performing the batch operation through the JDBC driver. Similarly, we can also use the JPA item writer for handling the database operation using JPA. So in this example, we will use the JPA item writer for storing the data using JPA to our PostgresSQL. And then we have job repository. The job repository does all the hard work, such as recording the status of your job within a database. It also keeps track of which job is running. If a job is completed, then it records the status of your job. As well as if there is a failure during the execution of your job, then it keeps track of at what step the job was failed in. This is very important for jobs that need to be restarted after a failure, and it can ensure that the jobs can pick up where it was last left off. So now that we understand the basics of Spring Batch, let's jump straight into the implementation. In this example, we will use the chunk-based processing for reading the CSV file data and process it and then store it into the PostgresSQL. For managing the database migrations, we will use Flyway. If you are not familiar with Flyway, then check out the link in this video description. I have created a dedicated video that explains about configuring Flyway within your Spring Boot project. Now let us create a new project and call it as Spring Batch Demo. And this project, I want to create it as a Java-based project, and I'm using Gradle with Groovy for managing my dependencies. Then for group ID, let's use it com.stacktips.app. And for the package name, let me remove this. So make it the same, com.stacktips.app. And because I'm using the latest version of Spring Boot, which is Spring Boot 3.2, it requires minimum Java 17 to work. And then for the dependencies, let's use Spring Boot batch. And then we can also use the Lombok dependency to generate our boilerplate code, such as getters, setters, and builders. So let's use Lombok. And because here we will use the PostgresSQL database, we need the driver for the PostgresSQL. So let's use the driver as well. And in this example, we will use the Spring Data JPA. So let's select JPA dependency. And for managing our database migrations, we will use Flyway. So let's select Flyway here. This is all we need for our application. So let's create a project now. Now our project is created. So let's look into our build Gradle file. Just verify that all the dependency that we have added is present here. Okay, so the first thing, Spring starter batch. So this is for doing the batch operation from Spring Boot application. Then we would need Spring Boot starter data JPA. So this is for performing our database operations using JPA. Then we have Flyway core for managing our migrations. And also I'm using Lombok here. Lombok is completely optional. You can completely avoid that. But I'm using Lombok in this example to generate all my boilerplate code like getters and setters. And because in this example, we will use the PostgresSQL, I'm using the PostgresSQL driver here. So if you're using any other database, then you need to select the corresponding driver for that particular database. So before we make any code changes, let us first verify if my database is running. So right now my database is not running, and I'll be using Docker to spin off a PostgreSQL instance. Now for this, I have written a Docker Compose file. So this is how my Docker Compose file looks like. So it has the Postgres database name. Then you have the username and the password. The username and password is injected from my environment variable. If you don't have an environment variable, you could also very well hard code it here. So now let's start this instance. So all you need to do is Docker Compose up. Now as you can see, my PostgreSQL instance is running. Okay, if you want to stop it, just do a Control X, it will stop. Now let us run it in a detached mode. For running the instance in a detached mode, all you need to do is Docker Compose up -d. Now you see the instance is started, but it is not holding back your terminal. So let's check if it is running. Docker ps. Yes, it is running now, and it is running on the port 5432. Okay, so we need this port information to connect to our database from our Spring Boot application. Let's now go back to our application property, and there we will provide the data source configurations, such as the data source URL, username, password, and the driver class name. You can do spring.datasource.url, and here you can give JDBC PostgresSQL, and our instance is running on localhost, and the port it is running is 5432. So let's do 5432. And here we need to provide the name of our database. So let's call it Spring Batch Demo. Okay, so you can give any database name. We haven't created this database yet. We will create that in just a bit. After you provide the database URL, you need to also provide the username and the password. And you can do that through spring-datasource.username. And here my username that I've configured is Postgres. And for the password, I'm using password. And then we also need to provide a driver class name. So let's provide the driver class name. And here this will be Postgres driver. Okay, so now we have provided our database configurations, but we haven't created the database yet. Now let us create the database first. Now for creating the database, I'm going to use DB Visualizer. So it's basically a client that allows you to connect to different databases. And here in this example, we will connect to the PostgresSQL database. Okay, so I've already connected to my database. Now let us create a new database. Okay, so as you can see, our database is created. And if you go inside the schemas and public, there is no table. It's completely empty database. And in this example, we'll be reading the CSV file contained into the database. And let me first get the CSV file. So for the demonstration, I've downloaded a CSV file called customer.csv from GitHub. And as you can notice, this is a huge file of around 17 megabytes. It has, not sure how much, it's I think 100,000 plus records. It's a huge file. So we want to import all this data into our database. Now let's open that and see how the file look like. If we open that in an editor, as you can notice, it's a huge file. So we will import customer ID, first name, and all other columns except for the index. Now let me close this because it takes quite a significant memory. So let me close this, but we want to copy this file into our resources folder. It doesn't have to be in the resources, but for the demonstration, I'm keeping it simple. Okay, so now we have the database connection defined. We have also all the required dependencies, and then we have the CSV file that we want to import. So let's now define our domain model. So for that, let us create a new class called customer. And we want to create this class within my model package. Okay, so it created a customer class. Let's mark this as entity class so that it will be a managed type. And then we can also define the table property. So let's do that. Here we can define the name of the table that we want to create. For example, in this case, let's make it as customers. Okay, so we want to store all the customer data and the table name is going to be customers. Let's mark this with the data annotation. So data annotation is from Lombok, which will give us the getters and setters and toStrings and everything required for our customer object work. Now within my customer entity, let us define all the fields that we want to store within our database. So we need to keep it consistent with our CSV file, and I'm going to keep all these columns that we have. Now let me copy this one here, and then it'll help me to remember all the field names. So now let's do customer ID. And the last one is our website. So let's do website. That's it. So we have defined all the fields that we need in our database. And then this is complaining because it doesn't have an ID annotation. It doesn't know which one is our primary key. So let's define customer ID as our primary key. That's it. Our customer entity is ready. And now these are the fields mapped to our CSV file. So whenever we import the data, we have to create the object of customer for every single row and then store the data into the database. And the next thing we need to create a repository. And because we will use Spring Data JPA to handle all our database operations, so let us now create a repository for customer entity. And we'll create this within the repository package. So instead of a class, let's mark it as an interface. And this should extend our JPA repository interface. Okay, so now we have our repository ready and we also have our model or entity ready. Let us now deal with our database migrations. As we have discussed before, Spring Batch uses the database backend to maintain the state of the job execution. If in case a job fails in between, then it maintains the state where the failure happened so that next time when you restart the job, then it continues the job execution from the point of failure. So for this, we need to create a set of tables required for Spring Batch to work. and the schema for the tables are provided within the GitHub repository of Spring Boot batch project. So let us now get that schema, which is compatible for PostgreSQL. Now the schemas are present within the Spring Batch core package. If you go inside Spring Batch core and then inside the main and resources, here you have a package name org.springframework.batch.core, and if you expand that, it has the database schema for all different type of database. Okay, so we need to find the compatible schema for your database, and in this example I'm using PostgreSQL, so we need the create table schema for PostgreSQL. And for managing the database migrations, we have decided to use Flyway. So let us now copy this script here, and with this script we will create a changelog file within our project, which will automatically create all these tables required for Spring Batch to work. Okay, so let us go back to our project, and here, because we have added the Flyway dependency, it has automatically created the db/migration folder. Now let us now create a changelog file here. So normally a changelog file will have a version number. So for example, v1, and then we can use the separator. Separator is normally 2 underscores, and then you can give any descriptive name. So for example, you can say create spring batch tables.sql, and then paste the script that we have copied from the GitHub repository. Okay, I'm just doing auto format here so that this looks more readable. We also want to store our customer data into the customers table, and for that we also need a migration file to be created. So let us now create another changelog file, and here let's call this as v2 create customers table.sql. And again here we need a SQL script to create the table. And to reduce the length of this video, I have already created a SQL schema. Let me copy the schema from here. That's it. So let me paste it here. So this will basically create the customers table where we will store the data imported from the CSV file. Now we also need to configure our Flyway. We haven't configured that yet. So let us go back to our application properties. And here within my application property, I need to configure for the Flyway. So one thing you need to do is Flyway enable true. And then we also need to provide Flyway locations. And here we can say class path. Then we have db class migration. Now that is all we need for Flyway to work. Now if you restart your application, it will check for the schema history table. If there is no schema history table created before, then it will create the schema history table, and then it will execute your migration changelog files in the order that we define. Okay, so in this case, first it will create all the tables for the Spring Batch to work, and then we will create the customers table. Let us now jump into our Spring Batch configuration. So for that, the first thing we need to do is we need to enable the batch processing for your application. And to do that, we need to create a config class. So let us create a class called batch config. And let's create that within the config folder. Okay, so we created a package called config and then created a batch config class. So because it's a configuration, so let's first annotate this with configuration annotation. And then we also want to do enable batch processing. The enable batch processing annotation basically enables the Spring Batch capability within your application. And for every batch application, we will have a reader, a writer, and optionally, we can also have some processors defined for your batch. And most importantly, we also have to define the configuration for the job and the step. Okay, so let us now first create a reader, and our reader will basically read the content from the CSV file and then convert line by line into the Java object. And for this, we can use the flat file item reader. Because we are reading the content from a CSV file, flat file item reader comes very handy. So let us now define a bean here. Let's create a bean called public flat file item reader, and the type of the output that it will produce is customer type. Okay, and then let's call it as reader. Okay, so here we can create a instance of flat file item reader. Either we can create using the new operator, or we can also make use of flat file item reader builder. Okay, so let's use builder instead of new operator. Okay, so I'm going to create the instance of new flat file item reader builder, and this is also of type customer, then builder.build. And because we want to import a CSV file, and typically a CSV file will have a header row, and we don't want to import the metadata into our database. Okay, so we are only interested on data which is from the second row onwards. So that's why we want to skip the first row. So if you want to skip that, you can do that through lines to skip. Here you can provide a number, and in this case we want to skip the first line. Then you can also provide a name to your reader. So let's provide the name. Let's call it a CSV reader or CSV item reader. Then here we need to provide the information about my input source. Here in this case, the file. And here to do that, we can do through the resources, and to my resources method, I'm passing the class path resource. So my customer.csv file is present within my resources folder. Because of that, the class path resource will work. But if you have the file somewhere else, then you need to define your file path accordingly. And most of the CSV file normally will have a delimiter in the file. For example, in this case, we are using comma to separate the columns. And sometimes you could also have a different character other than the comma, for example, pipe symbol. Then you can also specify the delimiter that you want to use to separate your columns. And to do that, let's use delimited. Okay, so this defines that my file is delimited. And then you can also provide the delimiter. So in this case, it is comma. So let's use that here. And then we can call the names method. And to the names method, we need to pass the name of the columns present within your CSV file. So this is important to maintain the order of the columns as they appear within the CSV file, because these names will be used to map the value from each column to the customer object. So for that, these names have to exactly match. So what I did is I have copied here. Okay, it's a comma separated string, and let's pass that here. So it basically includes all the columns, including index. Now here, one thing to notice is even though we don't want to import the index to our database, we still have specified that here. So this should contain the list of all the columns present within your CSV. Now in the later part, I'll show you how to skip this and not import into our database. But for now, in the names method, we must have to pass all the columns as they appear within your CSV. Okay, the order is very important, and the order should match exactly the order defined within your CSV file. Now, after we define the names, the next thing is we need to define the field set mapper. So it's basically mapping the data from your CSV to your Java object. Okay, so here we can do something like field set mapper, and here let's create an instance of new bean wrapper field set mapper, and within this we can pass target type as customer. Now the bean wrapper field set mapper automatically maps each column to the Java object. Okay, so it takes the names here and it exactly match all these names defined within your CSV exactly to the Java object. But in this case, this will not work for us because we don't want to import all the data exist within the CSV. We don't want to import the index. Except for index, we will import all other columns. And because there is a mismatch, this will not automatically work. So instead of defining a bean wrapper field set mapper, we need to manually map each column. So let's do that. So here within the field set, I'll create a object of my customer. Now for that, let us now create a builder which makes it easy for me to create an object. I'm using Lombok for creating a builder. It is demanding for the constructor, so let's create a all argument constructor and a no argument constructor. Now within the field set mapper, here let's create an object of customer.builder.build, and here we need to manually set all the fields individually. Okay, so let's do that. Okay, similar to the customer ID, we need to map every single column that we have in CSV to our customer object. And for subscription date, it is a little different because instead of using a string type, we are using the local date. Okay, so for that, we need to convert the string to the local date. Let us create a utility class here. Call it as dateUtils. For this, let's annotate this class with utility annotation. And here, let us create a method, a static method, which will convert our string date type into a local date. Public static. So I'm going to use a datetime parameter because I know the date is of YYMMDD. So let us use that. Let's double check. Okay, so as you see, the date type is YYMMDD. Now by taking the datetime parameter, let us parse this. That's it. So now we have the parse date method ready. Let us use that within our field set mapper. And here we will use the subscription date. Now our reader is ready. We have created a customer object by manually setting the fields. So we did our own custom field set mapper. After creating the reader, we now need to create a item writer. And as we have discussed before, we will use JPA for storing the data into our PostgresSQL. So for that, let us create an instance of JPA item writer. So let's create a bean. And for the JPA item writer, we again need to pass the customer type. Again, similar to the item reader, we can create an instance of item writer here, or you can also make use of the JPA item writer builder. And for item writer, we also need to pass the entity manager factory bean. The entity manager factory bean is basically configured automatically by Spring Boot when you have the JPA dependency added to your class path. So in our case, we have added the JPA dependency here, and the entity manager factory bean will be auto configured using the auto configuration feature of Spring Boot so that it will be automatically injected here. Let us pass the entity manager factory bean. And here for the JPA item writer builder, we can pass the entity manager factory bean. So this is all you need to do for the item writer, and it will automatically use JPA for storing our customer details into the database. Now after creating the reader and writer, let us now configure for my job step. Okay, so like I said, every job will have one or more steps. So let us now first configure the bean for your step, and then we will configure the job. So let us create a bean. So let's make it CSV importer step. So here we need to inject the item reader as well as item writer, and we also need the job repository to be injected here. Item reader, so this is the item reader that we've created. Similarly, item writer, and we also can pass the job repository. And here we can also pass the platform transaction manager for managing the transactions. So these are the 4 things you need to create a step configuration. Now here we can make use of the step builder to create a step. So let's do that. And to the step builder, we need to provide the name of your step, CSV importer step, and then also pass the repository. And then we can provide the chunk size. Here the chunk size is going to be 50. So let's process 50 items at once. Okay, so let's provide that. And to the chunk method, we can also pass the transaction manager. Then we can provide the reader and writer configuration. Here, if you want to make the job to be restartable, then we also need to call allow start if complete. So what this method does is, if you don't provide this or if you make it false, the task will be executed only once. But if the task is completed and you want to be allowed to be restarted, then we need to provide this as a true. Okay, so that is all we need to do for creating the step configuration. Okay, so we need to provide bean annotation for all these methods. We forgot to do that. Let's do bean. Okay, same thing here, bean annotation and bean annotation here. That's it. So we have created the reader, writer, and the step configuration. The next thing we need is we need to create the configuration for the job. And to create a job, we need to know the information about the step that you have. If you have multiple steps, then you need to pass all the beans for the steps. And also we need to provide the job repository. So let us create a bean of the job type. So like I said here, we need to pass the step configuration, CSV importer step, and also we need to pass the job repository. Now here again, we can make use of the job builder. So let's make return new job builder. And to the job builder, we can pass the name of your job builder. Let's use the same name here. And then pass the repository. And here we can provide a incrementer. So incrementer is basically will automatically assign a ID for your job, and every time you run your task, it will create a new incremental ID. So let's use the incrementer, and then here we can use new run ID incrementer. And then we need to provide the step configuration, and that can be done using flow method. The flow method defines the flow of the job, and if you have multiple steps, then you can define it here. But right now for this example, we have one step, and then let's make it end. When you make it end, that marks the end of the job flow. Now, if you have multiple steps or multiple flows, then you can call that using the next method. Okay, so you can pass a instance of a flow, or you can also pass a step. But in this example, we have only one step, so we don't need that. Let's call end, then build. Similarly, let's make this as a bean, declare this as a bean type. So we have created a reader, we have created a writer, and also we have configured the step, and then we have configured the job. Okay, so this is all you need to do for your batch configuration. Let us now create a trigger that will start my job. The job can be triggered from different methods. Either you can trigger a job from a command line, or you can have a REST API controller to trigger your job, or similarly you can write Spring scheduler to schedule your job based on a cron job, or you can also do for application events. So in this example, let us use the application event. we will use the application ready event, and whenever my Spring Boot application is ready, it will automatically trigger my job. So for that, let me create a new class under my config folder, and here let's call this as application event. Let's mark it as component. Now within my application event, let us now configure a listener for my application. So I want to listen for the application ready event. Okay, application event. Here let us mark this with annotation event listener application ready event. So whenever my Spring Boot application is ready, it will now come inside this method and it will trigger the application event method. Now within this method, we will now launch the job using the job launcher. So to trigger the batch job, we need two things. We need the job launcher and also the information about your job. So let us inject those two instances here. Now we can inject this through the constructor, but because I'm using Lombok, I don't want to create my own constructor. So instead, let me use the required argument constructor. That's it. Now Spring will inject the job launcher and the CSV importer job to me. And here, let us now trigger this job. So all you can do is job launcher.run. And here we need to pass the CSV importer job. Then we can also pass the new job parameters. Okay, so this can throw an exception. So we need to add the exception to the signature. That's it. So now we have created a trigger that will trigger our CSV importer job. Okay, so now we have created everything. We have the reader, we have the writer, the step, and the job. So after we configure that, we have also created an application event where we will trigger our batch job. We haven't created any processor yet, but we will see that in the later part of this video. Now everything is ready. Let us now run this application and see. Okay, it has successfully applied the migration schemas that we have created. So all our change logs are applied, and then it must have created all the tables necessary for us. Now, as you can see, our application is running fine. We don't have any problem, and the Flyway migration is working as well. And it has created the necessary tables for us because our table was completely empty. So it has first created the schema history table, and then it executed all the changelog files we have. So we had two changelog files. So both the changelog files have successfully applied. That means that it must have created all the necessary tables for our Spring batch to work, as well as the customers table for us. Then it has started the batch job, and it started my importer step. Then let's see what happened here. It has completed successfully. Okay, so it has imported all the customer data. Let us now go back to our database and we will verify if the data has been created. Now inside my database viewer, if you go under public, as you can see, it has created all the necessary tables for us. For example, it has created all the batch tables, and also it has created the customer table. Now let us go inside customers and see the data. Okay, so it has imported all the customer data into our database. Now let us check the columns. We have subscription date, city, company, customer ID, email. So we have all the fields that we wanted. Now, if you look back into the batch job execution, you can see that it has executed once and it is successfully completed. And inside our schema history table, we had two migration changelog files, V1 and V2, and both of them have been successfully executed. Okay, so far our batch application is running fine, and it has imported all the data into our database tables. Now, what if you want to create a listener for your batch application so that you want to know when your batch is completed, or if there are any errors you want to know about that? So if we have to do that, then we can make use of the job execution listener, and the job execution listener provides you two methods. It provides you a before job and after job. Okay, so let us create a listener now, and within my config, let me create a import job listener, and the import job listener will implement job execution listener, and this is of a component type. Now here we can override the two methods. One is the before job and after job. Let us use the slf4j for logging. Now within the before job method, let us add a log statement, and this log statement will be printed when the job is started. Okay, so let us now also print the name of the job. You can get that from the job execution instance. So you can do job execution.getJobInstance.getJobName. And here within the after job, we can also get the status of job, and we can do that from the job execution object. If job execution.getStatus. For example, I want to print a log when the job is completed or failed, then we can do that here. And similarly, let's do for the failed status. Now this custom job listener can be added to the job, and we can do that here in the job configuration. Okay, so let's provide listener, and here we need to pass the object of the listener. So for that, we need to inject the object first. So let's inject that here, import job listener. Okay, so that's it. Now let us run this application. As you can notice, the listener is now invoked, and we can see that in the log right here, the importer job completed, and similarly, it will also print when the job is started. So this is how you can attach a listener to your batch job. Now, so far, while starting the job, we're not passing any job parameter because it's completely empty. But think about a scenario where you want to pass certain parameters or input for your job, and you can do that through the job parameter. So now let us see how to use the job parameters, and we will try to get those parameter values from within the job. Now, instead of passing an empty job parameter, let us now use the job parameter builder, and we'll pass a certain parameter. So in this example, let me pass the countries to ignore. So when importing the customer data, we want to make sure that we ignore the countries that customer belongs to. For example, in this case, we don't want to import the customer that belongs to India. So now let's pass the job parameter. So we'll use the job parameter builder and add string. As a string, we will pass ignore country. So this is the key, and the value is going to be India. So we'll accept these parameters, and then we will ignore all the customer that belongs to India. So this is how we pass the job parameter to the job. Again, this is a very simple use case, but you can customize for your complex scenarios or business requirement you have. Now let us create a custom item processor, and within the item processor, we will read the job parameter that we are passing to the job, and based on the job parameter we provide, we will ignore the customers that belongs to the country India. So for that, let me create a new class here and call this as custom job processor. Again, mark this as a component type, and the custom job processor will implement the item processor. It will basically process a customer type object, and the output type also will be customer. Now this item processor will be called after the item reader completes its job, and the item reader passes the customer object to the item processor. Once the item processor completes the work, then the item writer will be invoked. Now at this point, if my process method returns null, what it means is we don't want to process the data, and that data will be ignored. So here we need to read the job parameter, the ignore country parameter that we are passing to the job. And based on the job parameter, we will ignore all the customer that belongs to India. To access the job parameter from the processor, we need to obtain the job execution that is linked to the current execution context. Since the item processor doesn't have any direct way to access the job parameter, here we need to use the step execution listener to inject those parameters before this step begin. So for this, we can do through the job scope annotation, and let's add that here. The job scope annotation can be used on the processor to bind the job lifecycle on the processor. So this will allow us to inject the job parameter directly into the processor using the Spring expression language. So let's create a variable here. And here we can pass the Spring expression. And here within the process method, we can write a condition to ignore the customer that belongs to India. So for that, let us put a condition here. And if they belongs to ignore country, then let us put a log statement. Okay, so I'm just printing the customer that is ignored based on this rule. Otherwise, we will return the item. That's it. So it's pretty simple. We have now created a variable called ignore country. And here we are using the Spring expression language to inject the ignore countries parameter that we are passing. And then we have just written a simple condition here. Now let us go back to our batch configuration, and here we need to use the processor. Okay, reader, processor, and writer. Custom job processor. That's it. So this is all you need to do for your processor to work. So we have now reader, processor, and writer. Let us now run this application and see how it works. Okay, so now as you can see, it is now printing all the customers that are ignored. For the job configuration, we can also define a validator to validate the job parameter that is being passed to your job. For that, we can use a validator, and here we can use the new job parameter validator. So now the job parameter is passed into this validate method, and based on this job parameter, you can write whatever condition you want. So here, let's say we want to validate if the ignore country parameter is Costa Rica, then we want to throw an exception. Then let's add the condition here. That is all you need to do to validate the job input parameters passed to your job configuration. This is all for today. If you like this video, please give a thumbs up. And if you have any question, please let me know in the comment section below. I'll happy to answer as soon as possible. Thanks for watching, and see you in the next one.